Hello everyone, welcome to lesson 7-6, cross sections. We will continue to answer the question, how does geometry help describe real-world objects? And the vocabulary is quite long for this lesson. We're going to learn about prisms, bases, pyramid, plane, coplanar, parallel, polyhedron, edge, face, vertex, diagonal, skew lines, cylinder, cone, and cross-section. Okay, a prism. What is a prism? Well, a prism is a three-dimensional figure. These are all three-dimensional figures, okay? But they're not all prisms. So it's a three-dimensional figure with at least two parallel congruent faces called bases. Congruent means same, right? Same size. And parallel means they're side by side. So they don't touch, but they're side by side. It's kind of mirroring each other, mirror. So you can see here that, for example, this side is parallel to this side, and they're congruent, they're the same size. And this length, right here, this panel, is the same as the back one. It's congruent, right? So, and they're called bases, and they are polygons, okay? Polygons. So that's a prism. So we're going to identify which ones are prisms and which ones are pyramid. So what's a pyramid? A pyramid is also a three-dimensional figure with one base that is a polygon. Only one base. So it doesn't have parallel congruent faces. It only has one. Its other faces are triangles. So look at this right here. You see the base? It's a rectangle, right? And all its other faces are triangles. It doesn't have another face like this one on the very top. So it doesn't have another congruent face or base over here as well. Okay, you can see here that we have a right angle triangle, okay, which is a polygon, okay? And then we have another triangle and another triangle and another triangle on the back, okay? And then over here we have a right angle triangle with a parallel congruent right angle triangle on the back that is parallel to it. And then you can also say we have rectangles and rectangles and rectangles. Okay, so let's identify them. If you think you know the answers already, simply based on the definitions, go ahead and write it out. Pause the video now and write them out. And then play the video and check your answers. Pause now. So the first one is a prism. It has, as we mentioned, congruent sides that are parallel to one another. Next we have a pyramid. Only one side, only one base that is a polygon, and all the other sides are triangles. And we have another pyramid. Now this is a triangular pyramid, okay? This is a rectangular pyramid, right? That's the base, a rectangle. This one, the base, is a triangle, so it's a triangular pyramid. And lastly, we have another prism because it follows the rule that it has congruent faces. This face right here, it's congruent to the back face. Congruent, okay? Now where can we see a building where we can implement this knowledge? Well, right here. This is the Rock and Roll Hall of Fame. Is the shape of the building a prism or a pyramid? Well, we can see that it's got triangles that meet at the very top on a vertex, but at the bottom it's a rectangle. If you were to see it from a bird's eye view, right? It's a rectangular pyramid. So the Rock and Roll Hall of Fame is a rectangular pyramid. This is a key answer, everyone. A quick review from grade 2 or 3 math is learning about different shapes. A shape, okay, or a polygon with 5 sides is called a pentagon. With 6 sides, a hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. And 10 sides, decagon. Okay, and remember, if you don't remember these, just take the time now, about a minute or so, to try to review them. Okay? Okay, let's continue on with our vocabulary. So identifying three-dimensional figures. A plane is a flat surface that goes on forever in all directions. A plane, okay? Just think of a surface, The figure at the right shows rectangle ABCD, ABCD, line segments AB, so a line segment is just a line, do you see that? AB, and DC, DC, are coplanar because they lie in the same plane, plane, meaning they're on the same surface, okay? This line is on the blue surface along with this line is on the blue surface. They're part of the same plane. This is our plane right here, okay? So they're coplanar. You see the word plane and planar? Co is like when you use the word coexist, cohabit, okay? To work together, to be a couple, you understand? Okay, so this is why we call it coplanar, because they are sharing the same plane. They are also parallel because they will never intersect no matter how far they are extended. You see how this is a straight line and this one's a straight line? This means they're going to continue on straight forever, infinity, and this one too, forever, on in both directions. So they'll actually never touch, and that's why we call them parallel lines. So just as two lines in a plane can intersect or be parallel, so the opposite, intersect is when they touch, or parallel is when they never touch, there are different ways that planes may be related in space. Okay, so here's an intersect line. Okay, we have this plane that goes this way, okay, like this sheet, and this plane that goes this way, and they intersect right here in the middle, right? It's lines that intersect. This line intersects with this line. But what if we're looking for a point, an intersecting point? Then we have to find it right in the middle of where they intersect. So this plane stretches in this direction, and the blue plane stretches in this direction, but then we have to find the center point. So we would have to cut it in half to find that center point halfway down each plane. See that? Okay, so that's an intersect point, a very specific place. And then when they have no intersection, it's because this plane continues on this direction, and this one continues on in that direction, and these are called parallel planes. They'll never touch. So now we're familiar with what a polygon is. But when we take more than one of these polygons, okay, and we create a three-dimensional figure with a polygon, we get a polyhedron. So let's read. Intersecting planes can form three-dimensional figures. A polyhedron is a three-dimensional figure with flat surfaces that are polygons. Prisms and pyramids are both polyhedrons. Some terms associated with three-dimensional figures are edge, face, vertex, and diagonal. So much like the edge of a cliff, we have the edge where two planes intersect in a line. So this is the edge of this cube, for example, the edge, or the edge of a table, and so on. So two planes are meeting and they create an edge. Then we have a vertex, where three or more planes intersect at a point. So this would be a vertex right here. Okay, we have the bottom plane meeting with the side plane, which meets with the front plane. And all of these three planes or panels are meeting here, and this is what we call a vertex. So pretty much a corner. A face is a panel. So this is a face. So how many faces does a cube have? Well, we see 1, 2, 3, 4, right? To go around like this, that's 4. But then we have 5, this one, and the one in the very back is 6. So we can count 6 different faces. Our face is a flat surface. And finally, diagonal. When we talk about a diagonal point, we're talking about the complete opposite. So you see here we have this bottom corner, okay, or this vertex. If we go to the complete opposite, which does not meet any of these panels, so for example, it will not touch this one, nor the bottom one, and we go completely across from B, we will hit H. This is a completely diagonal vertex. So this line segment, whose endpoints are vertices, okay, so this is a vertex and this is a vertex. The plural of vertex is vertices. are neither adjacent nor on the same face. And this is what we consider a diagonal. Okay, continuing on now, I realize that we are looking at many different terms, so it would be good to rewind and watch some of these parts again, and maybe even make yourself a little vocabulary list. So, notice in the figure above, line GC and line DA, so line GC right here, and line DA right here, do not intersect. Okay, they have nothing to do with one another. They don't share the same plane because this plane is a horizontal plane and this plane is a vertical plane, so they don't relate. They do not touch, so they don't share an edge or a vertex. Okay, so these segments are not parallel because they do not lie in the same plane. Lines that do not intersect and are not coplanar, are not on the same plane, are called skew lines. So these are skew lines. Yeah, another skew line would be H and E is skewed to GC. A and B is skewed also to GC. Do you see? And finally, there are also solids that are not polyhedrons. A cylinder, as you see right here, a cylinder like a tube or a pipe or even a bucket. A cylinder is a three-dimensional figure with two parallel congruent circular bases connected by a curved surface. So this circle here and this circle here are congruent parallel circular bases. Okay? And they are connected by a curved surface connected by this pipe. A cone has one circular base, as you can see there, connected by a curved side to a single vertex. So it's curved and it has a single vertex, this point. Okay, now let's take a look at all the ways we can identify some of these pyramids and prisms. Okay, now we're going to identify every single face. We won't often do this, but this is a way for us to show that we've mastered this skill. So we're going to actually dissect this to its maximum and identify every face possible. So identify the figure. Name the bases, edges, and vertices. Then identify a pair of skew lines. So this is as much as we can possibly get from this polyhedron. So let's see. The figure. Okay, let's take a look here at the figure. We have 1, 2, 3, 4, 5. So a 5 side is called a pentagon, correct? Now what's it called together? Okay, it's a pentagonal pyramid. Okay, it's a pentagon, so it is a pentagonal pyramid. And what is our base? Well, our base consists of, now, where you might be wondering, where do we get all these letters? You simply just pick letters of your own to name each vertex. Okay, each vertex, so the vertices. So our base is R, R, S, T, U, V. Okay, that's our base. And then the faces, well, our base is one face, right? And then we have QVR, QVR, QRS, QRS, this side right here, this triangle. Then QST, QST, right there in the front. QTU, right there on the side. And then QUV over there. Okay, so clearly we have 5. Since we have 5 sides to a pentagon, we have 5 triangles that meet at the vertex Q. So what are the vertices? All of the letters, right, that we assigned. And a couple of skew lines. Okay, skew lines, remember, they have nothing in common. So QV, let's see here. QV at the very back, right there. Okay, and TS. They don't share plane, okay, and they don't share a vertex. Okay, the same applies for this rectangular prism. Notice that we've labeled each vertex with a letter, and the figure has rectangular bases, okay, bottom and top. They're parallel, and they are congruent, they're the same size. So it's a rectangular prism. The bases. Here's where we start to identify all the bases. Now the base can be the bottom part, but because this is a rectangular prism, any side could be a bottom part, depending on how we set it on the table. For example, if this were a box, this could be the bottom, this could be the bottom, this could be the bottom, or this could simply be the bottom. So the bases all have to be named. A, B, C, D. You see that? A, B, C, D. E, this one over here. E, F, G, H. D, C, G, H. A, D, H, E, and then the last one, B, C, the very back, G, and F. Every single face is considered a base. Therefore, you'll see the same letters for the faces as the bases. Okay, so that's been established. So for a rectangular prism, the terms base and faces can be interchangeable. Edges. And now we start saying line AB. You see, line AB is an edge, line BC, line CD, line DA, line EF, all of these lines, okay, as long as you name the letters where the line ends, okay, and the little line on top just means line, okay, there you go, those are all the lines. And then the vertices, every single letter that we have on there is a vertex, it's a vertex. And skew lines. Okay, let's see two lines that are not, that do not share a plane, that are not coplanar, and that are not parallel. I know that I have A and F right here, and sorry, A and E right here on the side, A and E, and then F and G right back there. They don't share a vertex, they don't share a plane, and they're not parallel. Okay, now here we have our shape or our object. If you think you understand how to do this, please pause the video and try to fill all these out, and then press play once you're done to check your answers. Pause now. Okay, what do we call this figure? Let's see. The base is looks to be a right angle triangle, but they're not telling us it's triangle, but it's still a triangular base with triangular sides. So this looks to be a triangular pyramid. And the base is a triangle. They could be either side. Right now it's lying on the JLM side, the JLM side right there. But it could really just lie on any side. It could lie on the KML or the KMJ. So I went ahead and named all the sides. And the faces will be the same. So I just copied the same as the bases. Edges. Well, we have all these edges, and remember to use the symbol for line. So we have line. So then you go ahead and you label every line that you see. Like for example, line JL is line JL, line JK, line JM, line ML, line MK, and line KL. Okay, I think I got them all. And then the vertices are each letter. So each vertex where lines meet. And then finally skew lines, two lines that do not share. So here I have KJ, I could put that. Line KJ, right here, KJ, and line ML do not share a plane, and they do not share a vertex. So line ML. There you have it. The intersection of a solid and a plane is called a cross-section of the solid. So let's say we have this solid box right here, and I decide to cut it right here, and I want to address the one point right through the middle, right there. Okay, I want to know this specific point right here. We call this a cross-section. I've cut it down the middle, and I want to know this cross-section right there. That's what we mean. And here are some examples of cross sections. You see this pyramid here, this we've done a vertical slice. Okay, so the cross section is triangular. After you've sliced it down the middle, it's triangular, right? Over here, the cross section is being sliced at the top, kind of like an iceberg, and we're just cutting the tip of the iceberg. This is an angled slice. It's coming down on an angle. Okay, it's not totally vertical like this one. This one's an angle. Okay, so the cross section is a trapezoid. What we're leaving, okay, is a trapezoid at the bottom. Okay, and then over here, a horizontal slice, perfectly sliced. The cross section is a square. Okay. So just to review, cross section, the cross section that we slice, when we slice it down the middle, we get a triangle right there. Do you see the cross section is a triangle? And when we slice this one on an angle, we left the trapezoid, where one side is shorter than the other. See, this side, this angle is longer than the other, so we left the trapezoid. And when we slice it perfectly horizontally, we leave at the very cross section on this plane that we're bringing across is a perfect square. So let's describe the shape resulting from a vertical, angled, and horizontal cross section of a cylinder. So here's my makeshift cylinder, and the first one we're going to do is do a vertical cut. Okay, if I cut it vertically, like so, okay, and let's say I'm able to slice it right down the middle like that, all right? And this is my cross section in here, okay, in here. What shape do I get? I would get a rectangle, right? Just the same way when we see it from the side, or from the front, we get a rectangle. Well, if I slice it down the middle, I'm going to get a rectangle. If I angle it, let's say I'm able to angle it, and I slice it in this shape, what am I going to get? Well, if I match my angle with my circular shape in the angle, I should get an oval, something that looks like that. Correct? I should get an oval. A stretched out circle. And then if I slice it perfectly horizontally, okay, and I slice it perfectly horizontally, I should get a perfect circle, just like the top and the bottom of my cylinder. Does that make sense? Okay, and here's our guided practice. This is how we will start next class. Feel free to take a look at it and get comfortable with the content, and if you have any questions, we will address it first thing in class. See you then. Bye-bye.